Okay, so let's do another example of integration by parts. Here we have the integral of x times ln of x dx. And again, the tip-off that I want to do integration by parts is that I can't use u substitution. If I had x ln of, say, x squared, for instance, x ln of x squared, that I was trying to integrate dx, well, I'd see that here I have something which is the derivative of the thing that is being plugged into the ln function. So I have a function of a function times a scalar multiple of the derivative of that function. I could say u is x squared, du is 2x dx, and I could rewrite this as 1 over 2 integral, with a slightly nicer integral sign, integral of ln of u du. But I don't have that pattern here, right? It's just a first power of x, so I'm going to do integration by parts. Again, using my formula, integral of u, and by the way, it's a product as well. That's the other thing that's a tip-off. It's not that if it's not u sub, it has to be integration by parts. It's a product of functions, and integration by parts, it works backwards in the product rule, and you pick which one in the product is going to be u and which one is going to be dv. So that's the other tip-off. So I put my integration by parts formula. Integral of u dv is uv minus integral of v du. And then I said about picking which one is going to be u and which one is going to be v. So here I'm going to set ln of x is equal to u. This gives me du by dx is 1 over x. du is 1 over x dx. And then I get dv. So this is my u part taken care of. And my dv is going to be equal to, well, what's left over, I just have the x there. So it's going to be the x. That means that the v is going to be the integral of x, so it's x squared over 2, and we don't put in the constant for integration by parts, because it just complicates things unnecessarily. And so the idea is that this works, right? dv is still x, because x squared over 2 is an antiderivative of x, right? We're not looking for the general antiderivative of x, just any one will do. So I can substitute these in, and I get the integral that I'm looking for. This thing from way up there is going to be equal to u times v, which is ln of x, times v, which is x squared over 2, and then minus integral of v, which is x squared over 2, times du, which is 1 over x dx. And immediately I can see that this was the right way to go with it, right? Because this is a much easier integral to compute than the one that I started with. So this is minus x, I'll pull out the 1 over 2, dx. When you do integration by parts, it should make the integral that you end up with, generally speaking, easier to deal with than the one that you have. There's situations where that's not true, where you end up with like a multiple of the one that you have. We'll see that in later examples. But generally speaking, you should end up with an easier one that you know how to integrate. So it's very helpful to think a little bit ahead in integration by parts. So now we have ln of x times x squared over 2 minus 1 over 2 integral of x dx. And the integral of x is, of course, x squared over 2. So this is going to become ln of x times x squared over 2 minus 1 over 4 x squared, after I multiply that 1 over 2 by the 1 over 2, and then plus the constant. So that's it, but is it? Is it actually it? Well, I want to check before I move on with the test. I want to make sure that I haven't made some silly little mistake somewhere and I lose marks. So I take the derivative of this thing with respect to x. How do I know that it's the antiderivative? Well, I take the derivative and see what I get. So minus 1 over 4 x squared plus c. This is d by dx of ln of x times x squared over 2 minus d by dx of 1 over 4 x squared plus d by dx of c. And of course, on tests and assignments, you don't have to do every little step like this. I'm just doing it step by step too, for the purposes of teaching. But you're not gonna, you don't even need to put in the c to check, right? The c is going to go away, so don't feel like you have to do this every single time. So this again, this is the product rule we have to use here. Product rule. It's d by dx of ln of x times x squared plus times x squared over 2, rather. X squared over 2, can't forget the 2, times d by dx, or plus ln of x times d by dx of x squared over 2. And then minus 1 over 4 d by dx of x squared. I can pull the 1 over 4 out. And then plus 0. The derivative of a constant is 0. And the derivative of ln of x, of course, is 1 over x. So I get 1 over x times x squared over 2 plus ln of x times derivative of x squared over 2 is, of course, 2x. And then I'm multiplying it by ln x. And then this is a 1 over 4 times the derivative of x squared is 2x, of course, 2x. And I can do some canceling. The squared cancels with the x. The 2 cancels with the 4 and becomes a 2. And I end up with, oh, and this was, I also can't forget this, 2x ln x over 2. So these cancel. I end up with x over 2 plus x ln of x minus x over 2. And the x over 2's cancel. And it's just x ln of x, which is exactly what I was looking for.